Because they've started. Only 5 people. Abiodun is here.
Okay, good morning, class. Good morning. If you are not muted, please kindly mute yourself. We are going to continue, so I'm starting right away. I know we just have about 4 of you on the call. I'm going to finish up with alcohols. I just have about 2 slides to get through with alcohol. Then after alcohol, I'll move on to phenols. Then after that, I'll finish up with ethers. The slides on those 2 subject matter are not that many. But to finish up with the alcohols, I just want to give some little bit of review so that, for us to catch up. Now, if you look at the slides that I'm sharing now, my slide, you'll see it's talking about classification of alcohols. And one thing you need to look at when you want to identify the different classes of alcohol is to identify the carbon to which the functional group, the hydroxy functional group, is attached. We normally call that carbon the head carbon, So if you can see my cursor, you see that in this case, for example, this is the carbon and this is the hydroxyl group. This is the carbon, this is the hydroxyl group. So to distinguish between the classes of alcohols, identify how many alkyl groups are attached to that head carbon that bears the functional group. So if you look at this one, for example, that if you see my cursor, you see that the OH is on this carbon, and this carbon has only one other alkyl group. The other substituents are hydrogen and hydrogen. So because it has only one alkyl group, it makes it a primary. If you look at this one, this again, the head carbon, it has one alkyl, a second alkyl, that makes it, and then the third is just hydrogen, that makes it a secondary. And then this one, the third one has carbon, hydroxyl group, one alkyl, 2 alkyl, 3 alkyl, that makes it a tertiary. So I just said I need to point this one out. Like I said, this is just like a review. If you look at this slide is very, very important. It tells you that alcohols can be prepared from so many other organic compounds. So you can get alcohols from alkenes, you can convert ethers to alcohols, you can convert aldehydes and ketones to alcohols, you can convert epoxide to alcohol, you can convert esters to alcohol, you can convert acid chlorides, carboxylic acid, alkyl. So there are different reagents by which you can actually convert alcohols, all these organic compounds to alcohol. So I said this is also very, very important. And many times in the exams, you get some reactions. They give you a particular compound, and then it's supposed to go to an alcohol, and then they ask you to provide what will be the reagent and the condition. So I think it's important you guys get familiar with this. Having said that, the other thing again I want to talk about is like I said, we've gone through all this, but just a kind of review is to say that there are also different, so we've talked about different methods of converting organic compounds to alcohols. Then alcohols also have different reactions. Alcohols also have different reactions. Dean, I'm in class, please. Alcohols also have different reactions. For example, so you can oxidize. Let me go back. Like I said, this is just a small review. You can dehydrate in terms of preparation of alcohols. You can dehydrate alcohols to alkenes. That's one reaction. You can take an alcohol, you can oxidize it to either an aldehyde or a ketone using different oxidizing agents. You can take an alcohol. Okay, if you want to convert an alcohol from an alcohol to an aldehyde, it's very important you make sure that you use an acid that is mild, an oxidizing agent that is mild. If you use a strong oxidizing agent, your alcohol, if you see my cursor, this alcohol will not stop at the aldehyde stage. It is going to get converted to a carboxylic acid. So, which means that anytime you want to convert an alcohol to an aldehyde and stop, the kind of reagent you can use is pyridinium chlorochromate, which is a mild oxidizing agent. So if you use reagents like sodium dichromate, this is also an oxidizing agent. You can convert a secondary alcohol to a ketone. If you take sodium dichromate and use it to react a primary alcohol, it is not going to stop at the aldehyde state. You are going to end up converting the alcohol to the aldehyde.
So sorry, sir, we can't hear you, sir. Excuse me, sir. Good morning, sir. We cannot hear you.